Cristian Cornea, right?
Yes.
Okay, perfect. Is the founder of Zero Trust Security, and topic that you also can see in this speak is he will show us how to bypass antivirus using BadUSB.
Yeah.
But then you have to also say which kind of antivirus, so we cannot you can avoid it.
Yes, for the purpose of this presentation, we'll use the Defender, so we'll be like vendor neutral, but we will show some statistics. Firstly, before starting, I want to ask you a simple question. Do you still rely on Windows Defender to protect your computers, personal things?
Which one? 365 or?
No, the Defender, the basic one that comes with default Windows. So, but do you rely on antivirus, or do you have like an advanced endpoint protection on your PC? Both? Okay.
Corporate laptop, so.
Yeah, I mean on personal. So on personal. No, so it's just an antivirus, maybe some trial or free antivirus or something like this. Okay. So during this presentation, we'll see how we can bypass antiviruses using the little BadUSB, and we have it right here. 1 second. So we have it right here. As you can see, it's a little device. It's like any other BSBs. You see, it's like any other BadUSB. So we will use this one to bypass antivirus. Some words about myself. Founder of Zero Trust Security, also the president for Romanian Cybersecurity Training Center of Excellence. I have given some certifications over the past years, and trainer for multiple entities, and speaker to some conferences, also including BSides, WASP, DEFCON, Unbreakable, and also part of the scheme committee for SECURITY certified digital hacker certification. As a side note, I'm not responsible for the NMAP questions, if you know about them within the Czech certification. And when I find some free time, I write on Medium also. What is the agenda for this presentation? So we have some ANSI bypass techniques, execution policy bypass, payload runner development, and putting everything together on a little BadUSB. Then some tips and tricks to how to persist after the exploitation, the live demo, and some prevention mechanisms. And we'll go in details with each of them. Regarding the scenario, we have our users. In this case, we have Bob. Bob goes to the parking lot to take something from his car. He finds a little device near his car. He will bring that device, unfortunately, to his office. And there, into the office, he will plug the device into the computer, corporate computer. This scenario seems familiar to you. Have you seen it before?
Yeah.
Yeah. Maybe not finding USBs in parking lots, but finding USBs within the office or finding USBs home and plugging it corporate.
Alibaba store.
Sorry?
Alibaba store.
Or from Alibaba store. Yes. You know, this one was bought also from such markets. And when you buy this little device, be sure to test it in a isolated environment, because mine, for example, came with a sito reverse shell on a IP address in Kazakhstan or something like this. So it's better to test it first before plugging it into your actual personal or into your corporate device. And you can do that within a VirtualBox machine, or we can do that within a just purely isolated hardware laptop or PC. Okay, after Bob inserted the USB, what happened? Basically, an attacker has now control over Bob's computer. And basically, Why it is possible? Because Bob, firstly, Bob has a Windows Defender enabled, up to date. Bob is using a low privilege account within the Active Directory, and Bob computer basically has a policy to not allow removable media storage to be inserted, read it, and write it on its device. So we'll see how we can do that with all those policies in place and with all those mechanisms in place. And the sequence of attacks is the following. Firstly, in order to evade the antivirus, we'll develop an AMSI bypass technique. Then, in order to evade the low privilege account, we'll do the execution policy bypass. Then we'll have a payload runner in the order to inject everything within the memory to be fileless. We need to move stealthily and very fast. And some tips and tricks to post-exploitation. Firstly, we'll start with the AMSI bypass technique, which is the one that we use to evade the antivirus. And what is AMSI? Back to the basics, AMSI stands for anti-malware scanning interface, and think about it as a middleman between your antivirus product that you have and all the scripts, all the PowerShell scripts, for example, that you run on your device. Because of AMSI, have you wondered why we can have two antivirus vendors on a Windows machine? It's because of the AMSI. So it can intermediate just one antivirus with the scripts that we run. And it uses this AMSI scan buffer function from the AMSI.dll library to scan for any malicious content and any malicious behaviors for PowerShell. Basically, what is our purpose here, what is our goal, is to patch the AMSI scan buffer function with a value that will allow us to run any PowerShell scripts. How we do this, we'll see during the next slides. Firstly, starting to build our payload. Do you know what code is this one? What is it?
It's loading APIs like repetitive injection. No, it's get process load libraries of kernels into and changes memory properties.
Okay, the purpose is to change memory properties, but here we are just defining the functions.
Yeah.
So we are defining the getProp address, the load library, and filter protect. And those, you are correct, are Windows native functions from kernel 13. PowerShell doesn't know how to grab those. Yes, and here we use C#. So we use C# here to grab those libraries, and we convert using other type to PowerShell. And then going to the exploitation itself, loading the AMSI.dll library, as we've seen during the last slide. We need the AMSI.dll library because we need next to find the address of the AMSI scan buffer function. Because our purpose, again, is to patch this function, is to make the function return a value, the same value every time we run a PowerShell script. And using the virtual protect that we just previously defined within our PowerShell, we will make the function writable in memory. Okay, so we have the memory address for the AMSI scan buffer function. We made it writable. Let's see with what value we replace the function. And the replacement is this one. Do you have any idea about this value?
It's result of the AMSI scan buffer.
Yes, so this one will be the result of the AMSI scan buffer. So we patch the AMSI scan buffer function to return this value every time it scans a file. But why this value? We'll see during the next slide. Here, doing a Marshall copy technique, we patch the address in memory and we replace with our bytes here. And why this value? Basically, this is Microsoft official documentation for the AMSI scan buffer function, And as you can see here, this is not pretty important, but this one, return value. If coding, if this function succeeds, it returns s underscore OK. Otherwise, it returns an h result error code. What is the issue? What is the problem here that Microsoft didn't point out within their documentation is that if the function returns an h result error code, the script scan will run. So what we can do, we can patch the function to return an h result error code every time it is called within the memory. That's why we use this value. And this value is not randomly taken. So it's not randomly taken. It's actually an h result value. And this is also Microsoft official documentation. It's an h result error value for one or more arguments are invalid. So we successfully patched the function to return this value in order to run the scripts regardless of their malicious state or not. And we have our payload. And now a little question, what would you add to this payload to make it more undetectable and more hard to read and to debug? Obfuscation, exactly. We can use something like invoke obfuscation from PowerShell to make it look like this. But the challenge with obfuscation within this script is the following. It contains C# code and also contains PowerShell code. When you apply obfuscation, be very aware that if you apply obfuscation over the C# code, it will not de-obfuscate in memory correctly. So you need to apply obfuscation only over the PowerShell code. If you want really to apply obfuscation over the C#, you can do like in this example, you can just change the variable name. But that's at maximum. No more like this. You'll break the add type function if you place obfuscation over the C# code defined within PowerShell.
So, Chris, sorry.
Yes.
So you cannot do obfuscation inside C# code inside.
Yes.
Right.
So this one should not be obfuscated. As you can see here, the PowerShell is obfuscated with normalized functions, with replacement of hexadecimal values. So it's heavily obfuscated, but this one cannot be. The add type function will break the entire C# code.
Another question for one question. If I were to have like base64 with inside, like I don't know, SOR encrypted, it would do the same trick.
That's a pretty nice one. What you can do actually, if you want to go,
I mean, I define a long string there, and
exactly. If you want to go this path, you can do the following. You can have a base64 of this one, put it in variable, then apply base64 decode over the variable, and then pass it to add type.
Okay.
That's a good one also. That's a very good one. Yes. Execution policy bypass. Let's see how many of you run into this error. I mean, it's pretty common, right? Yeah. You cannot run signed scripts. You cannot run untrusted scripts in PowerShell. But what happens that because we as normal users, we can bypass this without any administrative privileges. We can set execution policy to unrestricted, and we can set it to apply for our current user. So we can actually bypass the execution policy for our own user. And we discussed with Microsoft about this one, and you know what it said? It said it's basically a feature. It's actually a feature, this one, and we said, okay, it's a nice feature for attackers, for people that want to run malicious PowerShell scripts. Like for me, because I'm coming from an offensive side of things, but think about somebody who's coming from a more defensive side of things. Like it's pretty dangerous, right? And an alternative for this one to block PowerShell scripts is through Active Directory group policy. So it's much better than this one. Okay. Next one. Yeah, it was just like this, a string, nothing more complex. Sorry if you expected something more technical, comprehensive, but that was just it. Next, let's see how we can develop a fileless payload runner to inject everything into the memory. Firstly, we have the lookup func value, and we are not going to too much details here because it's pretty late. But this one is used to search for assembly references within the memory. You'll have also the source code for those after the presentation. Next one, we have the getDelegateType function, which is used to set the argument types. What happens? We discussed previously, right? PowerShell doesn't know about Windows native functions, so we used C# to define those. But PowerShell also doesn't know about the argument types for those Windows native functions. For example, we don't have pointers, we don't have integer 32, we don't have all those argument types. And we need a special function to define those argument types because we'll pass to other functions, to other Windows native functions that we'll call later. And we define this function. Next, just allocate some space using virtual alloc for our shellcode. As you can see here, 3,000 bytes were allocated, while our payload is 2,000 and a half. So yeah, just be sure to allocate a little more than you need in order to have some error space, or just allocate. Do not allocate less than your payload, and be very aware and try to see how many bytes your payload will be before allocating this space within the memory. And then the shellcode was generated using MSV Venom, so pretty catchable, pretty detectable, or maybe not. We'll see. So it should be pretty detectable. And then we define the value here, the variable, just copy paste from MSV Venom output to our payload runner. And also using the same Marshall copy, we can copy the value of the buffer within the pre-allocated memory space. And then here we call the create thread in order to execute this memory zone. And as you can see here, we pass some integers, some pointers to the function of create thread with the getDelegateType. Okay, so we now have a payload, a full payload. How we can use it with BadUSB? How many of you heard about rubber duckies? Okay, perfect. So rubber duckies are very similar to BadUSBs, or BadUSBs are very similar to rubber duckies. Let's not be like, no. Okay, and basically, what's the main difference? As you know, rubber duckies are some devices that simulate the mouse and the keyboard. The same is BadUSB. And basically, what's the main difference between a BadUSB and a rubber ducky is that a BadUSB is cheaper than a rubber ducky, so we can use it for mass deployments of attacks, like dropping 20 of them in a parking lot. Because if we try to calculate 20 of BadUSBs, might be 1 or 2 rubber ducks. So that's the report, price report. And also, BadUSBs are a little slower than rubber duckies, but that's it. For the price that we pay for them, that allows us to compile, not to compile, but to translate ducky script to Arduino script. So it's pretty straightforward. If you are not comfortable with C++, you can use the Arduino. And the ducky script syntax is very user friendly, like that. So this is the ducky script syntax. As you can see, everything that we type after the string, it will be executed by our BSB. For example, here, make dir loot. It will execute, it will type make dir loot on the target computer. And we have delay if you want to put some sleep, because sometimes BadUSB can be, or rubber duckies can be faster than the computer that we target. Windows 7, Windows XP, seen them, can be faster, and the target computer, the victim, will crash while processing a lot of keyboard inputs. So we can put delay in order to slow a little bit and let the operating system to process all the payloads that we insert. Rem is used for a comment. Repeat, basically, it's a loop of the last commands x times. And here, very important, enter, control, tab, shift, delete. All those must be written in the rubber ducky script as they are written on the keyboard itself. And guy is basically the Windows key, and we can control over the mouse with mouse_move and with the coordinate that we want to point the mouse to. And we have also left mouse, right mouse, and middle mouse, which are the mouse buttons that we want our BadUSB to press. And some post-exploitation for system tips. It's pretty simple. As we can spawn Metasploit, a Metapreter before shell, we can use the migrate command to elevate or migrate to another process, like store the text or something like this. Okay, and let's now skip to the good part, which is the demo. Then we bring up here. So for the demo, we'll simulate like a real life scenario. We are now Bob, and attacker has an AWS sito infrastructure, and I'm starting it right now. So we have a command and control posted in AWS external to show that there is no sito into the internal network. So we have an external sito. We have Windows Defender up to date, and it's running. Real-time protection is running, which means that also AMSI is running here. And 1 second, to connect to our infrastructure, and we'll spawn a Metapreter before shell. And after that one, I have another surprise for you that you can do. After spawning the shell, yes, I'm putting right now. Okay. SSH. Yeah, I know it's a bad idea to have SSH deployed in the internet with open port as a sito command and control, but we are authenticated with private key. So okay. it's somehow fine. Somehow. Where is Tali? Yes. Okay. 1 second. Here. Oh. Okay. Make this and here we have the sito command and control. Let's open the listener. Sudo msv console, pretty basic. Starting.
Sorry, can you change the font size?
The font size? Okay. 1 second, if I can here. Size. Not this one. Change settings. Appearance. Font. 1 second. second one, let's try with 16. Maybe it's not right. It's better?
Yeah.
Oh, perfect. Good. So we have here, where's my mouse? Oh, there it is. We have here the metasploit. Let's use the exploit multi-handler listener. And the payload, we'll set the same payload as we set as the one during the shellcode generation. So set payload Windows x64 matter red reverse TCP. I think I typed matter red. Okay. Set listening host 0, 0, 0, 0 to catch everything, and set listening port, the same port that we set during the shellcode generation. So set L port 443 and run. Okay, now we have the reverse discipline handler listening, actively listening, and I hope it will open. Let me see. Oh. Okay. Can I change my? No. 1 second. Let me show you now the security settings. Okay. No, somebody connected to us. Okay. Let me switch here. 1 second. Oh, no.
sempre dentro mi
Okay, let's see. We have the real-time protection on. Okay. And okay. You will not see basically too much here. Can I change my screen to 1 second? Sorry? Let's insert the BadUSB. I'll try to it will open PowerShell, but it will be seen here, and I'll try to change the console. I want to have this screen on the so we are inserting the BadUSB now, and I'll try to copy the screen. So it will try to open PowerShell here, and I'll try to copy the PowerShell screen there.
Vabbè, in ogni caso non lo vedresti.
Yes, it's right. It's right.
Netto si quindi sì, c'è
can I use this screen basically? Yes. No, it's typing now. It's typing.
Yeah, I'm not
Leave it typing. Is it typing? Oh, or leave it like this, and I'll take the. So now the BadUSB is actually typing, and because we have the duplicate screens, I'll bring the screen to you. It will execute the BadUSB on the main screen, and I'll bring immediately after the execution, or just give me 1 second.
maybe the mirror mode.
easier, but can we mirror it? 1 second, just leave it to. No, it's wait.
Yeah, but you're also streaming, so I have to check that it will work also for the live
So
stream.
just now it will type everything. Okay. Give me 1 second. Give me 1 second, please. Okay. Let me see how to do it. Okay. What I'll do, actually, I'll insert directly the BadUSB and wait for it to execute and then bring the console to
Ok, qui se lo chiudi funziona. Tutti fanno test con cosa aperto. Poi lo puoi passando.
And here we have the payload executed. And let's see shell. We have a shell here, and as you can see, let me do something else. Let's do something smarter. Load mimikatz. Let's see if it works. Yeah, pretty some Ruby errors, but here we have mimikatz loaded with Windows Defender, where it is. Here it is with real-time protection on, mimikatz loaded, all straight from this BadUSB. So, demo, some prevention mechanisms. Firstly, disallow cut PowerShell entirely for end users. You can do that through GPOs in Active Directory, group policies, and then apply access control lists on USB ports, on physical USB ports. Switch a little bit the mentality from antiviruses to advanced endpoint protection solutions, and also security awareness for users. Train them in order to not be like Bob. Bob is the worst case scenario here. And yeah, that's mainly it. And some research and statistics. This one was reported to Microsoft. They are not considering it worth their attention. And it was also tested on 20 antivirus vendors with free and trial versions. 7 from 20 found a meta-predator reverse shell, which allowed mimikatz to be loaded directly into the memory. 9 from 20 just a normal reverse shell. And 4 from 20 block entirely the exploitation attempt. And that's basically it. Some questions or discussions or curiosities? Yes, please.
Which feature of the AB block did your attempts was for?
At type. Or which feature you mean?
Of the AB products,
Behavior.
memory scanning or something.
Behavior.
Okay.
Yes.
Have you tried this in corporate environment, CDRs and productive CDRs?
not EDRs, but manage antivirus. For EDRs, it's not working. So, and this one is not working. That's why it's called bypass antiviruses and not bypassing EDRs. Yeah.
That makes sense.
Yeah. But for antiviruses, it's pretty effective, and also for managed antiviruses.
Great. Thank you.
Yeah, you can. As we are finished, so we are free. Just two things that I would like to say thank you to you to still be here. Ok, allora se potete aspettare 5 minuti, sì, chiediamo che siamo qua.
Salve. Salve a tutti. Grazie per essere rimasti gli ultimi coraggiosi. L'evento è andato bene. Come avete visto, noi in trasparenza dietro le quinte abbiamo un po' assistito, non tanto trasparenza, a volte siamo abbastanza ingombranti, diciamo, a buona presenza. Comunque, come avete visto, noi ci occupiamo anche di questo, di tutta la parte di divulgazione, quindi se volete ci trovate, abbiamo una grossa presenza online, abbiamo dei canali su Twitch, YouTube, abbiamo un server Discord dove c'è una community adesso di 400 persone circa. Ci occupiamo di questo, facciamo divulgazione, facciamo aggregazione, ci occupiamo anche di servizi aiutiamo le aziende a trovare professionisti, aiutiamo le aziende nel branding, aiutiamo le aziende nella formazione e anche chiunque ha bisogno comunque di andare avanti nella propria carriera, nella propria verticalizzazione. Quindi siamo disponibili sempre per una chiacchiera, quando volete venite sul server, vedete comunque gli sticker, abbiamo il QR code, quindi ci potete trovare in maniera molto facile. Che altro dire?
Ciao, un applauso a Security Team. Senza anche la presenza online è stata bella complessa, per non dire impossibile, quindi congratulazioni a tutto lo staff, perché poi diciamo, non so quante persone eravate lì, ce n'erano che lavoravano dietro le quinte, quindi che hanno permesso di fare questo evento.
Qui avevamo mezzo staff, uno staff di una trentina di persone, qui eravamo in 15. È stato un piacere stare qui con voi.
Grazie per l'organizzazione.
Grazie a tutti.